Hello and welcome to this video, mathematics standard level, higher level, mathematical studies, whatever you want. We're going to be talking about triangles, and it's basically an introductory video to trigonometry. Now, to begin with, I want to, in this presentation, what I would like to do is take a look at the things that you probably already know. And when I say already know, is things that you've probably seen in secondary school, GCSEs, ESO, whatever. Now, here are basically the main ideas. Now, you probably know how to calculate the area of the triangle. You probably know that the angles of triangles always add up to 180 degrees. You probably remember something about Pythagoras' theorem. Maybe you've heard about Thales' theorem, and maybe you haven't, but once you see the theorem, you'll realize that you probably have studied something very much like this. And you probably studied the sine, the cosine, the tangent, and I put etc. because there's a bunch more things like the secant and the cosecant, but we're just going to concentrate on the sine, the cosine, and the tangent right now. Now, these things, maybe you remember them, maybe you don't. The purpose of this presentation is to run you through these 5 points. So let's go for it. The triangle. Well, here's a triangle. The pink thing here is a triangle. Now, if you look at the way I've done this drawing, I've completed the rectangle, right? And you know how to calculate the area of rectangles, basically base times height. And if you think about it, this rectangle here that you can see essentially is going to have the base of this rectangle is going to be this part of the base. It's going to be the height. And this other rectangle here, the rest of the base of the triangle would be the base of that small rectangle, and the height would be the same. And if I calculate, therefore, base times height, and I divide the whole thing by 2, I'm going to end up with the base of this triangle. And that's exactly the formula, which you probably remember. Area equals base times height divided by 2. Now, it's interesting, and I leave it as an exercise to think about whether this rule actually applies in this type of triangle. It's called an obtuse triangle, but more about that later. Give it a shot if you want. Give it a shot. Try to think about how is it that I can do a similar explanation to the one I just gave for this one for this triangle here. Now, next thing. The next thing is the idea that all the angles of a triangle add up to 180 degrees. This is particularly useful. So here's an example of a triangle, and I have the areas here, 17.5, 105.74, and 56.75 degrees. And if you add them together, indeed, you get 180 degrees, or very close, because these, of course, are rounded numbers. Now, here's my recommendation, something that I believe that you should give a shot, something you should try. Just take a triangle, and, take a piece of paper and cut a triangle out of it. Once you have a triangle, cut the corners and join them together. I've done something similar to that with this triangle here. Here would be the alpha triangle. Here would be the gamma triangle. And here is the beta triangle. And you see, can you visualize if I actually join them together, they'll form a line. That's because the angles add up to 180 degrees. So that's a general rule for any triangle, and that's a particularly useful one that you don't want to forget, because it might save the day in a hard exercise. Now for Pythagoras' theorem. Now, Pythagoras' theorem is a kind of theorem where a lot of mathematics teachers have a lot of fun teaching it, because there's all sorts of tricks and games you can do with it. It's taught in every mathematics program in any schooling system around. So I'm just going to give you a very simple reminder of what it is. And here's the one I think is more useful for you to visualize. I want you to think of the idea of a square area and remind you of this idea. Here's my triangle. You see, I'm going around this triangle. Now, I take this side over here, and if I square it, what I mean is that whatever this measures, I'm going to multiply it times the same thing, and that area, the number that I get, is actually going to be the area of the square formed by sides that all have the length of this side of the triangle. Similarly, I can take this side of the triangle and build a square with it. And the area of this square will be this length squared. And the same thing with the hypotenuse. What Pythagoras' theorem tells me is that the area, the number that I get when I square the hypotenuse is equal to adding up the numbers that I get when I square the sides, the A side and the B side. And you can also think about it as the area of the square where all sides measure the same thing as the hypotenuse is equal to the area of this square plus the area of this square. Now, there are so many ways to prove this. There's a particularly cool one that I would like you to show. So if you happen to bring some papers and some scissors, and perhaps we have time to do it in the classroom, you can really feel the way this works and how it's a perfect proof. But then, again, there's hundreds of different ways to prove this one. Now, Thales theorem, this is the one that maybe you don't remember. Here, let me just draw two lines cut by two parallel lines. Here's what it looks like. Okay, so I have two lines here, this line over here, and this line over here. And I'm going to cut them with one line CB and another line ED. This angle, incidentally, is 24.44. That's not that important, okay? Not right now. What Thales theorem tells me is that if I take, for example, BC, that's this length here, okay? And I divide BC, and I divide by what AC gives me, right? You see, like this probably measures, let's say this measures 1, then maybe this measures what, like 2, then, you know, I can divide the CB divided by AC, and I get, well, I get something like 0.5, 0.41. Great. Now, here's the thing. Whatever number I get when I divide BC by AC is going to be exactly the same number as if I take DE and I divide it by whatever AE measures. See, they both give me 0.41, and I didn't tap in these numbers. This was actually calculated by a program. So it doesn't matter. It doesn't matter whether I take this small triangle or this bigger one. The ratio, the proportion between this side and this side will be the same as the proportion between this side and this side. Now, this is going to change if the angle changes, but it's going to stay the same if the angle stays the same. So really, this ratio, this side divided by this side, only depends on the angle. That's very important. This is true for AB divided by AC compared with AD divided by AE, and also true for BC divided by AC and DE divided by AE, or am I sorry, and AD, sorry, and DE, excuse me, DE divided by AD. It says that this is wrong, you should say here AB, but never mind. The point is that if I take similar sides, their proportions are always the same. The ratios are always the same in the small triangle and the big triangle, and it only depends on the angle. That's Thales theorem. Just a small reminder here that there's another theorem that is often called Thales theorem, particularly in Latin countries like Spain, which talks about the complementary angle of a circumscribed triangle. But never mind so much about that. Let's just stick to this definition. The sine, the cosine, and the tangent are exactly the result of what we just talked about. So, for example, I don't really need to look at anything else but the angle. You see, if I want to calculate what this side divided by this side gives me, well, I know it's the same thing as this side divided by this side because of Thales theorem. And the only thing that makes it change is the angle. So the ratio of BC divided by AC, which is the same as DE divided by AE, simply depends on the angle. And since it only depends on the angle, it's the only information that I need. And I call that the sine. The sine of that angle is whatever any triangle opposite side measures divided by whatever that triangle that has this angle here, its hypotenuse measures. That's the sine. It's basically a ratio of the measure of two sides. The cosine is the ratio for that same angle of the adjacent side, the one that's next to the angle, divided by the hypotenuse. And the tangent will be the ratio between the opposite side divided by the hypotenuse. You can see now in this triangle that that ratio, by the way, is going to be 1 because they measure the same. A good way to remember this sine opposite hypotenuse, cosine adjacent hypotenuse, is with the somehow strange mnemonic SOHCAHTOA, which helps you remember these relationships. I hope that was helpful, and I'll see you next time. Goodbye.